Welcome back. Have you ever put numbers into a calculator and gotten an answer that has like 15 decimal places in it, and you weren't sure if you needed to record those decimals or if they were really important to the answer or if you needed to round them off? Well, the answer to that question lies in understanding significant figures. Significant figures are a convention in science that are used to indicate the level of precision at which data has been collected. And so the first thing we're going to do is look at a couple of, or four rules actually, that have to do with determining what numbers are significant in an answer. Okay, so we have, let's begin with our first rule, which says that zeros between other non-zero digits are significant. So let's take a look at an example of that. This number, 2002. These zeros are in between non-zero digits, and so all of these are significant. And so we say that this number has 4 significant digits, or sig figs. You'll hear people use that term. Okay, so this is 4 significant digits. Let's look at another example. This number also has 4 significant digits, because these zeros, these sandwich zeros, are significant. They do tell us the degree of precision at which this thing has been measured. Our second rule says that zeros in front of non-zero digits are not significant. For example, this number, these first 2 zeros are not significant. This one has 2 significant figures. Those are the 2 non-zero digits that tell us the degree of precision at which this measurement has been made. This example, how many significant digits here? Only 1. 1 significant digit or figure here. Our third rule says that zeros that are at the end of a number and also to the right of the decimal are significant. So, zeros at the end of a number, to the right of the decimal, those indicate the degree of precision. Here I'm making a measurement to the 100th place, so this number has 4 significant figures. Okay, doesn't matter how many I put behind there, they're all going to be significant. So this one has 7 significant figures. Must have been measured with a very precise instrument. Our last rule says that zeros at the end of a number, but to the left of a decimal, are significant if they have been measured or they're the first estimated digit. Now, here's an example. If I have this number, I really don't know whether or not I actually have 1,000 or I'm rounding somewhere close to 1,000. It's hard for me to tell whether or not those are significant, those zeros are significant. For our purposes in this class, if you see a number like this, it's 1 significant figure. We don't count these. We're saying that we're only being precise to the thousands place in this particular case. Okay? Same thing with this number. Okay? Only 1 significant figure here. We don't count the trailing zeros as significant if they're to the left of the decimal. Now here's a couple of exceptions. If you see a number that looks like this and it has a bar over the 0, that little bar means that they're saying yes, those zeros do count, and this is 3 significant figures. Even more rarely, you might see a number written like this, and that indicates the same 3 significant figures. But for the most part, if you see a number where there are these trailing zeros that would be to the left of the decimal, those are not significant. So there's our rules for determining whether or not a number is significant. All right, let's start with our rules for addition and subtraction, because those are a little bit easier than the ones that we have for multiplication and division. And basically the rules with addition and subtraction are that we look at the decimals, the decimal places, and that'll help us determine where to round off. So let's say we have this number here plus this number here. We add those together. Now, where are we going to round this off? We look at our pieces of our question here. This says only to the tenths place. This one is to the hundredths place. So our answer can be no more precise than the tenths place. So we look at this and we're going to round this off. Now, we're going to go over some rounding rules in just a little bit, but in this case, we look at the tenths place, then we look at the hundredths place. It's a 5. This is an odd number, and we have a 5, so we are going to round up. So our answer would be 103.2. Okay, that's the rules for rounding in addition and subtraction problems. Let's look at multiplication and division now, because in multiplication and division, the final answer is going to have the same number of significant figures as the measurement having the smallest number of significant figures. So all those rules that we just talked about, here's where they really come into play. So let's take a look at an example. Now here we've got tenths places here, we've got no places, only whole numbers in the first part of our question. But both of these have how many significant figures? They each have 3. So when we multiply these together, we get this answer. But this answer has 1, 2, 3, 4, 5 significant figures. We can only have 3. So we have to round off to those first 3 significant figures, and so our answer would be given as 658. Okay? Now here's those rules for rounding. Now, in your math classes, you've probably heard that if the next number is 5 or greater, you round up. And if it's less than 5, you leave it the same or round down. And that's pretty much true for what we're going to do in this class, but there's one little exception. Let's take a look at this number. Let's just use some examples here. How would we round this number to the nearest tenths place? Well, we look at the tenths place. It's a 2. We look at the hundredths place. It is less than 5, and so we are going to take that number and leave it. We're just going to drop off that 4. Okay? So we call that rounding down, even though it stays the same. We don't make the 2 in the tenths place larger. So anytime you've got a number that's less than 5 in the next place over, in this case the hundredths place, you're going to round down or leave it the same. Now let's take a look at this example. Here's another case where we're going to round down. Now here's where it gets a little odd. We look at our tenths place, we have our 2 again, but now we've got a 5. Now normally we'd say if it's 5 or greater, we round up. But in order to eliminate as much error from rounding as possible, when we do science problems, we kind of have different rules for odd and even numbers. So if the 5 is the last number, or it's followed by a bunch of zeros, and the number that we're looking at is even, so if this number is even and this is 5 and it's the last number or the last non-zero number, then we are going to round down and we leave this as 32.2. Okay? Now, when do we round up? Okay, we round up in situations like this. Here we're going to, again, go to the tenths place. So we look at the hundredths place. It's greater than 5, and so we are going to round up to this. Okay, now we've got another example here. Again, rounding to the tenths place. Look at the tenths place. Look at the next one. Here we've got a 5. This is an odd number, but it's also, the 5 is followed by other non-zero numbers. So in this case, we're going to round up. Okay. And remember this one up here where we had an even number and the last number was 5, or the last non-zero digit was 5? We rounded down. If you've got an odd number and the last digit is 5, then you are going to round up that number. So this would also be 54.8. Okay? So there's the rules for significant figures, and when we use those, and how we round numbers. And so now when you get an answer, follow these rules to determine which decimal places are significant and how your answer should be expressed. I also have included a sheet that you can download and keep that has notes on these rules that you can refer to if you are unclear about how to express your answer.